The relatively unknown fire ant is the object of several studies, like this one in Texas. When it takes over a new territory, the fire ant begins by multiplying. A colony could contain up to 40 million individuals. It exerts total domination over the territory it conquers. It exterminates all other species, confiscates food for its own use, and ferociously defends its territory. Its formidable efficacy places the fire ant among the most devastating invasive species of the planet. It is commonly called the fire ant because of the burning venom that it injects with its stinger, located at the extremity of its abdomen. 100 million years ago, Solenopsis invicta wasn't an ant, but a wasp. The fire ant inflicts considerable ecological and economic damage. Agriculture pays a heavy price. Plants providing shelter in their roots or leaves must be examined and treated before being commercialized. Young livestock and poultry who are stung by fire ants are major losses. It costs the American economy several $billion each year. In order to understand the devastating success of this seemingly insignificant insect, scientists study the fire ant's strategies to conquer new territory and test methods to control its expansion. Will they be able to parry the attacks of these troops whose thirst for new territory appears unquenchable? The fire ant's odyssey began in Brazil. Solenopsis invicta originated in Mato Grosso in the southern Amazon forest. There, the fire ants were in competition with other ant species who were just as numerous, aggressive, and protective of their territory. Forced to share the resources, the fire ants were not the unleashed conquerors they would later become elsewhere. Rather, they blended into the ecosystem and were not considered hazardous. It was man who unwittingly gave them passage aboard ships, thereby opening new territories where competition was not so fierce for the ants. In less than a century, the fire ant has taken over the southern United States, attacked the Philippines, overrun China and Thailand, and entered Australia.
The red-imported fire ants were originally introduced through the port of Mobile, Alabama, and the soil that was in ships, and then they would dump it was used as ballast to weigh the ship down. Then they would dump the soil out in the harbor to then take on the weight of cargo. And so the ants were in the soil and they slowly spread, and it took them many decades. This was in the early 1900s, and they didn't reach Texas until maybe the late 60s, early 1970s.
The change in biotope could have been fatal to the fire ant, but the opposite occurred. When the fire ant left its native region, its hitherto unsolicited but innate features were put to use. Professor in the entomology department at A&M University in Texas, Mickey Eubanks is a fire ant specialist. He has studied them for over 30 years.
Red imported fire ants are incredibly successful invaders for a number of reasons. And one of the reasons that they're so successful invading new territories is that they're very adapted to disturbance. For example, they can really handle flooding really well. So in their native habitats, they live in these floodplains that are prone to very severe flooding. And we see that here in the United States, where they can withstand flooding by forming these living rafts that allow a large percentage of the colony to survive in the water for a long time.
You can see the workers are amazingly strong. When I lift up with my forceps, you know, they'll produce these strings of workers that are just connected to each other. So they have very powerful mandibles and legs to make this happen.
Fire ants use their mandibles to cling to each other. This multifunctional tool is as powerful as a hydraulic jack. Workers hang on to one another, locking their mandibles and constructing a safety raft whose links are so tight the raft is water resistant.
Now, some of the workers that are forming this living raft, they're not going to be alive the whole time. They're going to sacrifice themselves. And they're willing to sacrifice for their sisters. And they're really willing to do this because of this unique genetic system that they have called haplodiploidy.
In a haplodiploid system, unfertilized eggs hatch to reveal males who are the worker ants. Fertilized eggs release females, the queen ants. As a result, a male carries only half as many genes as a female. Since evolution is based on the transmission of any given species' genes to the next generation, for the fire ants, it's preferable that the males, the workers, sacrifice themselves.
And that's what's happening here. They're actually, give their lives to prevent the rest of the colony from drowning.
Mickey Eubanks travels the world over to study fire ants. But it is on this lake that he leads his daily research on the surprising capacity of adaptation of this uncommon insect.
Oh, I see fire ants climbing up this dead tree. That might mean there's a raft that has touched the tree, and now they're coming off the water.
The raft is constructed in a few minutes. It floats because fire ants are hydrophobic. The chitin, which envelops the ant's body and protects it, is waterproof. The water ripples against the surface without entering the body.
It's made up of thousands of fire ant workers. Thousands of them are forming the basal layer that's on top of the water. And then on top of that layer will be hundreds or thousands of additional fire ants. Many of them will be carrying the larvae or the babies of the colony. They use those strong mandibles, their strong legs, to really hold on to each other.
When Mickey lightly pushes down on the raft, it doesn't sink. The very high density of the ants linked together ensures its cohesion. As such, a colony can float hundreds of kilometers on any type of water.
No matter how long you study these fire ants, they never cease to amaze you, and they're just so impressive. And then you can see some of the larvae, though, unfortunately for them, get used as sort of like life rafts. So this raft will stay together until it touches some emergent aquatic vegetation or something like this dead tree that we see here. And as soon as the raft comes in contact with the dead wood or the vegetation, the workers are just going to start scrambling up out of the water. And many of them, again, will be taking these larvae or the babies of the colony up the vegetation or up this dead tree to escape from drowning. That's their priority at this point, is to save the babies from drowning. Very efficient, very effective. Whoop, whoop. We don't want to get too close to the tree or they'll start coming in the kayak.
If the raft drifts for too long, the workers are forced to eat some of the larvae and eggs to avoid starvation. When the raft lands, the ants get off and find their way to dry land. The colony is safe. The fire ants, who have avoided drowning and survived famine, now look for new territory. Well adapted to the hazards of the humid tropical forest, fire ants are intrepid voyagers. They can climb mountains, cross rivers, and bypass deserts. Urban zones don't faze them either. On the contrary, if the fire ants discover a sizable piece of land, they won't hesitate to call downtown home. Walter Schinkel is the world expert on fire ants. His book, The Fire Ants, published in 2006, is the Bible for all those who work in the field.
I don't like the word invasive because it's a metaphor of war. My interest is not in fire ant eradication or control or anything like that. It's basic biology of ants. The main thing that is specialized about fire ants is its large colony size. We live in a hot climate, and the ants cannot travel those distances above ground. So they have evolved an underground foraging tunnel system. It's just a series of tunnels like rivers coming out from the mound that give them access to all parts of the territory.
Digging a tunnel in clay, sand, or pebbles requires adapted tools and technologies. What Walter Schinkel studies, life-sized, is the fire ant's behavior in man-modified terrain.
We have plots here, they're all 10 square meters. We've either tilled the soil, which is a disturbance, obviously. We've shaded them. Fire ants are reputed not to like shade, right? We get decent survival of newly mated queens in plots that have been tilled. Then we know that tilling favors their survival. If we get poor survival in untreated plots, then we know there's something there that doesn't favor their survival.
The looser the earth, the easier it is to dig. The workers spin a network of galleries, some of which dip all the way down to the water table, the layer of soil that is saturated with water. The workers never stop digging. They are constantly opening new tunnels, connecting them, and adapting them to climatic conditions. In warm seasons, the galleries provide protection from drought. In the winter, they provide warmth. Fire ants do not hibernate. They can withstand cold temperatures down to 10 degrees below 0 degrees Celsius. The nest is a veritable underground empire, home to up to 250,000 individuals.
The fire ant is an ecological specialist that exploits disturbed habitat. Now, in its home in South America, that disturbance was largely natural. But with the advent of humans and with the transport to North America, then, of course, most of the disturbed habitat is human-caused. So we clear land, we clear the natural forest that would cover the southeastern U.S. For agriculture, for building houses, for businesses, roadsides, parks. So once the ant arrived in the United States, it found itself fundamentally in paradise, because here was this vast amount of disturbed habitat. We call synanthropous species, that is, species that are associated with humans. It's been an extremely successful immigrant, at least as successful as humans, right? They are simply opportunists, that's all they are.
Some scientists have to travel the world over to do research. But Walter Schenkel has the privilege of conducting his research on the Florida State University campus in Tallahassee, where he teaches. With the help of his students, Walter has already exposed 15 meters of tunnels, which gives an idea of the digging capacity of the fire ant, barely 6 millimeters long, and of the extent of its underground network. Walter highlights the galleries with orange tooth powder. Non-toxic, the tooth powder dissolves in water. It allows the ants to be counted without disrupting them.
4 underground foraging tunnels that radiate out from the central mound give them access to every part of their territory. The system protects them from heat and predation, so they can travel long distances to cover their entire foraging territory.
Walter has also discovered that all the fire ants' nests are interconnected, a phenomenon called unicoloniality. Thousands of soldiers, for conquering or for defending, can be mobilized in the wink of an eye.
Here in the Tallahassee area, the mature size is probably 250,000 workers. In order to defend the territory, they have to blanket an area of, on average, 100 square meters with workers, foragers that go out, and that's how the boundaries are established when they meet workers from neighboring colonies. The average lifespan of a colony like that is about 7 to 8 years, and it's a single queen, so it's one giant family of sisters, and they're all complete sisters. There's one father and one mother. Territorial behavior is the core of fire ant biology. It's a species that defends an absolute territory against its neighbors, that is other. And it does so by sending out foragers from the central nest. They move through underground foraging tunnels and come up in various parts throughout the territory until they eventually run into foragers from the neighboring colony. And when they do, they are aggressive to one another, and they either fight and then run away, or they just turn back and run back into their own territory where they came from.
The local ant species called the harvester ant is much bigger than the fire ant, and yet it cannot measure up to the latter. In combat, Invicta displays an exacerbated aggressiveness that most often leads to the defeat or even the death of the adversary. Fire ants don't bite. They use their mandibles to cling to the enemy. Once they are solidly latched on, they inject their venom from the stinger at the end of their abdomen. They can sting 7 or 8 times in a row because, unlike bees or wasps, their stinger does not detach once stuck into the enemy's body. When the fire ant engages in combat, it immediately emits a chemical signal, an odor. When a fellow fire ant receives the signal, it arrives immediately as backup. Very quickly, a fire ant cohort takes down the enemy, which finally succumbs after the violent assault. The local ants are beaten. The fire ant's stinger is a mighty blade, spiked with harpoon-like points. The venom, colored here in red, is highly concentrated formic acid, like bee and wasp poison, and just as painful. The fire ant attacks all living things, humans, animals, and insects alike. Each year, millions of people are stung. More often, the stings leave no more than a bad memory, but the pustules may be infected and leave scars lasting for several weeks. Some fire ant victims die from anaphylaxis, or an allergic reaction to the venom, or because they are weak or disabled and unable to flee.